Now, these questions are very common in year 11, very common in year 12. It's just a matter of practicing and just working out what they're really asking. They're after, for this question here, find all the solutions for the sine of something equals negative root 2 on 2 in the domain 0, 4 pi. Now, what is it really asking? This is what it's asking. Can someone explain in your own words, with the unit circle, how can you translate this in your own words? Would anyone like to go? For example, what does sine mean?
Y.
It's the y. So we're really looking at the y coordinate and looking at the x. It's either going to be theta, like degrees, or radian. But looking at the domain, are we doing all our work in degree or radian? Radian. So we're looking at radian. What we're saying here, at what radian is the y coordinate, because we're looking at sine, at what radian does it equal negative root 2 on 2? So if I were to do a unit circle, what they're after, at what point going around the circle, are we going to get a y coordinate that's a negative root 2 on 2? Okay, so yeah, possibly. Yeah, good, Tim. We'll get there. We'll get to Tim's solution of 5 pi and 4. We'll do it step by step. So what we do in our working out is something like this. Now, you can do it visually in your head, but in maths, you do need to show steps. So even if you can get to the answer quite quickly, you've got to show logic. Remember doing that back in year 9. What do we call that? Okay, yeah, it's called, figuring out the theta. We're calling it the inverse sine. The inverse sine. Okay. Okay. If you got your calculators out and you put an inverse sine of root 2 on 2. Okay. Root 2 on 2. Or we can use our diagram. Which triangle are we going to use? The equilateral or the 1-to-1? The 1-to-1. Okay. Because root 2 is the giveaway. So that's 45 degrees or a pi and 4 on both sides. So you need the skill of searching. When you see things like root 3 or root 2, they're kind of indicators of which triangle to go for. We can see a root 2 here because this, remember, as you did, is a root 2. But if we do a sine, if I'm going to do a sine where it happens to be root 2 on 2, what's the other version of root 2 on 2?
1 on root 2.
A 1 on root 2. And if I do a sine of what angle? A sine of the opposite of a hypotenuse, because that's the sine. Well, really, there's only one angle that we're looking at anyway. It's the 45 degree, or the pi on 4, as Tim was saying before. So we know now that our angle, when we do inverse sine, we're actually working out the missing, it's either going to be in degree or in radian. The radian here, we know that to get a 1 on root 2 or a root 2 on 2, the angles are pi and 4. So this x is a pi and 4. But what have I missed out?
Negative.
It's a negative. In here, we need to account for that. Now, we have this thing over here, and a good way to remember it is cast. I touched on it last time. Does anyone recall what this whole cast diagram is about? Would anyone like to give it a go? Or today's lolly? Perry! Correct. Okay, what colour, Perry? Anything? Just not orange. Okay, I'll get you my favourite, green. So, as you can see, in this section here, both cosine, sine, and even tan, they're all positives. In this quadrant here, sine is the only positive one. Down here, tan is the only positive one. If it lands in here, cosine is the only positive value. I'm after a sine and negative. I want to read off a pi on 4. Which quadrant, C, A, S, or T, is there more than one quadrant where the signs are negative? T or C. Okay. Gabe, is that what you're going to say?
Yeah.
So T, by symmetry, T or C, we have our original pi on 4 there. By symmetry, though, we're after this one and this one here. So even though we had a negative here, even though I ignored it here, you can ignore it, but then make sure we account for it later on by drawing in the right pi on 4. So this is really incorrect. What do we really want? This is pi on 4. But can you describe this one here, Emily? If I want to describe this one here,
Be a
negative pi on 4, which would be this one. Okay. Okay, so we're going to do negative pi on 4. What's another way of saying we do want to avoid the negative pi on 4 though? What's another way, Emily, you could describe keeping it into a 3 pi on 4? Okay. Not quite. You're close though. I want to remember from this point here, instead of the 0, because we'll go negative, we're going to use 2 pi, and we're going to go forward or back. Back. So the first one is like that. Okay. How do we do this one, Jesse? From what reference point do I want to get from here? A pi plus pi on 4 is the first one. Now, I'm telling you now that's half correct. Gabe, why?
You have to take into account the domain.
Excellent. Okay, right now, Gabe says, Perry, we are half correct. Look at how many rotations we need to do. How many rotations, Zay, do we need to do? If it's from 0 to 4 pi, and one circle is 2 pi, 2. So we go for a little walk. Hit, 2 pi. We need to get up to 4 pi. So we go hit again, and then hit again. This third hit, what's the reference point if it's the second time round? Anyone? Good, Zach. 3 pi plus pi. Anyone know what the fourth one is going to be? 4 pi minus pi on 4. Good, Jesse. Great. Okay. Now we're just going to clean up our answers. You've got to be the cross multiplying. We want quarters, so 4 and a 4 gives us a pi. How many pi's in 4, Maya? 5 pi's in 4. Over here, I want quarters, 4 times 2. So we're going to change that into 8 on 4. How many do we have, Perry? 7 pi and 4. And then we keep going. 3 times 4 is 12. 13.4, and so on. Okay? You can do it your own way if you want to. This is the way I do it. And we're done. What is it saying? At these points here, the coordinate for the y, is a negative root 2 on 2 only. We're only interested in the y coordinate here, those angles, when we're going around this unit circle. Any questions with that? Very good. Which part? 4 answers? Yeah, okay, because of the domain. So this domain here is 0 to 4 pi. So 0 to 2 pi is 1 round. So go hit solution, there's 2. But then we're going to go to 4 pi. 3 pi, hit again. And then the 4th solution to get to 4 pi. Okay. We'll do a visual later in our last example. Does that click, Perry? Okay. I'm going to change it up. Right now, I want to do this. Cosine, do not be put off. What's that called again? Alpha, thank you. You need to be well practiced dealing with different symbols, and the domain is written differently. What am I doing over here? What do I need to change here of our focus? X coordinate. Are we still doing radian?
Yeah.
We are. So we're still finding out the radian. So in other words, we're finding out what angle or what radian is the x coordinate 0.7. We go around the circle. So let's do that now. Everyone get your either calculator's fine today. What mode do we need our calculator?
Yeah.
Let's put it in. Check it out right now. And punch it in. Do the inverse cosine, please. What answers did people get?
Yeah.
0 point. Did everyone get 7.7954?
Yep.
I hope so. What does that mean? That means, once again, is this degree or radian? Radian. Of 0.794 gets us to 0.7 x coordinate. So for example, if I travel 0.794 from the start, I want to stop until I've made a mistake, until it hits an x coordinate of 0.7. It stops right there. Okay. We still use our CAST. Is our original equation gave a positive or negative, and therefore which quadrants?
Positive.
It's a positive.
Quadrant 1 or 4.
Quadrant 1 or 4. Cosine is positive in the all section and also in its own section here. 0.795. Well, that way, and 0.79 pi 4 this way. So let's keep going. I'm going to move this out of the way because we need to refer to it. First one. What's our first solution if we're going to have a walk until 4 pi? What's our first solution? It's 0.7954. It's already there. I walk here, no hits, no hits, no hits. This is a hit. How do I describe this one?
3 pi minus that.
It's a 2 pi minus that. Okay. I've gone around once. How do I describe this one, Zay? If this is 2 pi minus that, then what's this one?
5 plus that.
Correct. And the last one, Nathan. I go all the way twice to 4 pi, but I need to go forward or back for this last one. If you don't know, it's okay. That's okay. Who knows what it is? It's a 4 pi back. Thanks, guys. That's all right. So all we need to do now is just calculate them off using your calculator. Because unless you're a genius, you can't do these in your head. So can you now punch those in? You should have got, if you're calculating them right now, these are the ones you should have got. Okay. So just a recap. These are the only points where there's an x-coordinate of 0.7. So this is 0.7 something, and this is 0.7 something. And these are positives. We're not interested in y. And these are the radians that we travel around where it hits those things within that domain. Two more to go. Change this. We're now going to do slightly different, something new in here. And we're going to do this in degrees. Going to do that. Just by looking at our answer, at our equals, which triangle are you going to work with?
60-31.
The 60-31. Which coordinate are we looking at, Jesse?
X.
X. And what do we need to do to our calculators now? Degrees. So punch it into degrees, please. Degrees, remember, is on the inside of the circle, radians on the outside. So let's do this. I'm just going to rewrite the question. Remember to find this angle here, we do an inverse cosine. I'm going to ignore the half here because the negative is going to turn out in our diagram. So, if I have a half, you've punched that in your calculator, you'll get an answer already. Does anyone know what it is?
Okay.
Cosine of 60. So the cosine 60 gets our adjacent over hypotenuse. Okay? So they're saying, what's the angle that creates a 1 on 2? It's the 60 degrees. Therefore, which quadrant, Perry, if I want a negative cosine, a negative x coordinate, which ones?
2 and 3.
2 and 3, correct.
We can put that on stupid. Like, I don't know which one's the name.
Okay, so we're after those. Now, this is something you've got to be really careful with. The moment you see, this is a really common mistake. Once you see in here something multiplied by the angle, does anyone know what that means? We have to do with the domain. We increase it by 2, by twice. So I'm going to times this by 2 and that by 2 because of this 2 here. So really, the domain that we're operating in is between what two numbers? 0 and 720. Okay. 720, think about it. How many revolutions is that? 2.
Right.
Okay. That's all right. Okay. So we're going to do 2 revolutions. What's here? We're not doing pi anymore. What's pi over here in degrees? 180. What's our first answer? It's going to be 180 what? Good. 180 minus 60. What's the next one? 180 plus 60. Okay. And then we go round again. What's the next time round? If this is 360, we go 180, 360. It's a 540. 540. What? Good, Nathan. And the last one is a 540 plus 60. Good. We're still dealing with 2 sets of theta. Let's clean this up. 120, 240. What's that? 480 and 300. 600. My bad. Now, the last step. I'm just running out of room. I'm going to work backwards now. What do we do now? Excellent. So to get our actual angle, we divide it by 2. We're just backtracking. 120 divided by 2. 240 divided by 2. 480 divided by 2. And 600 divided by 2. And you already got the answers in your head. 60, 120, 240, and 300. Now, the last thing I need to do for the term is this. We're going to now do a visual of what we've just done. Hopefully I've got enough space. It's going to be nice and rough. Now, what we're really saying, Look carefully. I'm going to use different colors here. Whenever you see an equal sign, visually, they're two graphs. We've got cosine 2 theta and we've got the graph of negative half. Now, from what you know about cosine 2 theta, let's look at the blue. How high is cosine going to start? At 2, okay? No,
No, one.
at 1.
It's just the 2 theta except
Okay.
the
That's right. The amplitude here is a 1. So we are knocking off 1 and negative 1 as our boundary.
oh wait,
That's right. Okay. Now, let's look at the, as Tim just mentioned, the period. Period is what over what? 2 pi on n. And this n is a 2, so period of pi. But don't forget this question's in degree. So period of 180. So therefore, if I measure, I just want to be accurate here. Let's use that. Let's just say this was 180. But notice our domain goes to 360. So we need 360 at the very start. But one cycle only lasts until when? 180. So I'm going to do this. I'm going to fit my cosine in like that. Okay. Have I finished? No. I need to go again. I know it's not very accurate. I'm just going to cheat and move my negative 1 down here. Now, last set, I now graph my negative half, which is simply there. This is negative half. And we are after when blue is equal to red. And where are they? Blue is equal to red here, 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 and here. But through calculation, this is about 60. That's 60 degrees something. This is 120. This is 240.
the y just negative 1.
Sorry.
Isn't the y just negative half?
Yeah, the y is negative half. That's right. It's its own graph. Yeah, it is. It is. It is. Correct. Thanks for that. I got lost a bit. So another way of explaining this, you can explain stuff with a unit circle, but you can now also explain things or need to understand that these are also graphs, an intersection between two things that are also graphs. And they hit at precisely where we want them. If I read them up here, that's exactly 300 degrees. Any questions?